inorganic chemist. I design and synthesize new molecules for specific biological actions or to answer specific questions in a biological context. Metal complexes have unique properties that can be exploited to interrogate living systems or to develop new therapeutics with original modes of action. In this context, I'm interested in two main axes. The first one is the development of metal-based probes that can be imaged in different biological environments, cells, tissues or organisms, using different and complementary imaging techniques. We aim here at the possibility to visualize, locate and quantify the probes in a selective biological environment. The second axis concerns the development of metal-based drugs, with a particular interest in cancer and pathological conditions related with inflammation and oxidative stress. Whatever the strategy we follow or the pathway we target, we aim at generating a whole picture of the biological activity of the compounds we develop, generating data on penetration, cellular localization, quantification, and biological activity. Complexes hold a great potential for new therapeutic agents. One prominent example that probably everybody knows of is cisplatin and its derivatives that are used largely in clinics to treat various cancers. Recently, more metal complexes have entered clinical trials with promising outcomes. So my research activities can ultimately lead to new therapeutics and in any case help the development of such drugs by providing a better understanding of how they work. Country this size, I find here in Singapore the research tissue in academia impressively dense, dynamic, diversified and interconnected. The first thing that comes to my mind is the enthusiasm of the people I met in welcoming new members in their scientific community and also in embarking on new projects and new collaborations. Yeah, absolutely. My main research projects are multidisciplinary by nature. So they require skills and techniques from synthetic chemistry, biochemistry, biophysics, cellular biology and so on, and therefore are conducted in collaboration with other teams or labs. On the imaging probes projects, my main collaborators are in France, particularly at Institut Curie and in the synchrotron Soleil. On the metallo-drugs projects, my main collaborators are here in Singapore. First at the Division of Chemistry and Biological Chemistry at NTU, where I have been hosted for the last 3 years, and also at the Departments of Chemistry and Pharmacy at NUS. With the closure of schools, having a toddler and a baby at home, my work has been quite impacted by the situation, and I also had other plans for the last few months that I spent in Singapore. I'm, however, more concerned with the situation of the students who are working with me, whose experiments had stopped entirely, leading to an important delay in the progress of their research projects. On a more positive note, the situation forces us to reinvent the way we communicate within the team, and I feel that somehow it helped to tighten the links. Also, more generally, it creates undoubtedly a new impetus in the field of drug discovery.